All right, in this video, we will learn how to use the chain rule to differentiate. We already know that if you have y equals x to the power n, then dy dx will be nxn minus 1. If you have y equals maybe x plus 2 all squared, you can easily expand this to get x squared plus 4x plus 4. And then you can differentiate to get 2x plus 4. That is simple. But what about this power is not 2? For example, is a number like x plus 2 equals 8. It will be difficult to expand this binomial up to a term. But we can use the chain rule to make it simple. For example, if we let any variable, let's say u, be equal to x plus 2, then we can see that y will be u to the power 8 because x plus 2 represent u. So y will be u to the power 8. Now, when we come here, u is a function of x. So we can only differentiate u with respect to x, the u dx. We cannot find the y dx. In fact, there is no y. It's u and x. If we differentiate u with respect to x, we have 1. Because when we differentiate x, we have 1. And when we differentiate 2, we have 0. And y is a function of u. So we can only differentiate y with respect to u, dy du. We cannot find the y dx because there is not even x. If we find the y du, we have 8u7 if we apply this method. But we know u equals x plus 2. So this is simply 8 x plus 2 to the power 7 because u is x plus 2. Now, we do not want the u dx or dy du. We're actually looking for dy dx. So we can see that dy dx is simply dy du multiplied by du dx. Because in this situation, we can see du can cancel du and we have dy dx. So dy dx is dy du multiplied by du dx. And we know dy du as 8x plus 2 to the power 7 multiplied by du dx. Du dx is 1. So 8 times 1 is 8. And we have x plus 2 to the power 7. Let's look at another example. If we have, let's say, y equals x plus 4, x 2x minus plus 4 to the power 4, we can say let's maybe u be equal to 2x plus 4. If u is 2x plus 4, then clearly y will be u to the power 4 because 2x plus 4 is u. So y is u to the power 4. Now u is a function of x. So we can only differentiate u with respect to x. We cannot find the y dx. After all, there is no y. It's u and x. If we differentiate u with respect to x, we differentiate 2x, we have 2. If we differentiate 4, that's 0. So 2 plus 0 is simply 2. Now we come here. Y is a function of u. So we can differentiate y with respect to u, not dy dx. After all, there is no x. If we differentiate y with respect to u, we have 4u to the power 3. But we know that u is 2x plus 4. So that is simply 4. In place of u, we can put 2x plus 4, sorry, and that is to the power 3. We do not want the u, the x, or the y, the u. We're actually looking for the y, the x. And that is the y, the u, multiplied by the u, the x. As we can see that in this case, the u can cancel the u, so it's the y dx. So the y du is simply 4 2x plus 4 to the power 3 multiplied by the u dx. The u dx is 2. So this leads to 4 times 2 is 8. 2x plus 4 to the power 3. So that's the final answer. Now, let's look at the answer and notice something. We look at this section of this answer and we look at this section of this answer. We can see that in this situation, when we find the y dx, this 8 is the power. So it's 8 multiplied by this entity, this element, which is x plus 2, reduced by 1, multiplied by the derivative of the expression in the bracket. This is 1. 1 is when we differentiate the expression in the bracket, because when we differentiate x, we have 1. If we differentiate 2, we have 0. So this is it. If you use y equals x to the power n, the y dx is n x n minus 1. We multiply the power by the base and we subtract 1. We multiply 8 by the base, x plus 2, and we subtract 1. We have 7. Multiplied by the derivative of the expression in the bracket. The same thing applies here. We look at this one from here. We can see that this is 4. The power is 4. So it's 4 multiplied by this element, which is 2x plus 4. And this is 3. That is 4 minus 1. So reduced by 1. Multiplied by 2. Multiplied by 2. That is multiplied by the derivative of the expression in the bracket. If we differentiate 2x plus 4, we have 2. So we can conclude that if we have y equals ax plus b to the power n, then dy dx by the chain rule equals n ax plus b n minus 1 multiplied by the derivative of the expression in the bracket ax plus b. If we have y equals ax plus b to the power n, the y dx will be n ax plus b n minus 1 multiplied by the differential, the derivative of the expression in the bracket. Let's use this formula for some other ones and see. Let's say we have y equals the square root of 2x plus 3. This is the same as 2x plus 3 to the power 1 over 2. So the y, the x will be 1 over 2, 2x plus 3. 1 over 2 minus 1 becomes negative 1 over 2, multiplied by the derivative of the expression in the bracket. If we differentiate 2x plus 3, we have 2. So 1 over 2 times 2 is 1. So we got 2x plus 3 to the power negative 1 over 2, or simply 1 over the square root of 2x plus 3. You can use the chain rule to check your answer. You get the same thing. If you have y equals s squared plus 3x, let's say plus 3 to the power 20, the y dx will be, this power is 20, so we multiply 20 by s squared plus 3. 20 minus 1 becomes 19, multiplied by the derivative of the expression in the bracket. If we differentiate s squared plus 3, we have 2x. So this is the same as 20 times 2x, that gives 40. X s squared plus 3 to the power 19. If you use the chain rule, you get the same thing. We can go on and on and on. Let's take the last example. Maybe y equals 2 over the square root of 3x plus 1. This is the same as 2 3x plus 1 to the power negative 1 over 2. So dy dx will be, we multiply negative 1 over 2 by the coefficient here, by 2. That will be negative 1. 3x plus 1, negative 1, negative 1 over 2 minus 1 over 2 becomes negative 3 over 2. Multiplied by the derivative of the expression in the bracket. If we differentiate this expression in the bracket, 3x plus 1, we have 3. So the answer is negative 3, 3x plus 1, negative 3 over 2. Of course, we can write this as a positive coefficient, doesn't matter. So that's how to use the chain rule. You can check your answer by using the chain rule. All right, if you like this video, please subscribe to my channel. See you in the next video.